Okay, we're learning about interpolation today. We'll do a quick review of some of the things you've been learning about for the last few topics. Statistics. This is, you're using this to tell a story about a data set. So within statistics, we had several statistical measures. So those were, for example, the mean, the median mode, the standard deviation, the covariance, and those are summarizing the data as single numbers. So then last week you had curve fitting, which, if you recall, you're taking a bunch of data points and you're fitting, some sort of analytical solution through that. So you're making predictions from a data set about the overall trend. You're not looking at specific points, but you're just saying in general what is happening with this data set. Okay, so today we're going to talk about interpolation. How many of you have done interpolation before in other classes? A good number of people. Okay, so you're also using this to make predictions, but they're different predictions. So now you're assuming that the data points you have are exact, and you're finding something, a new data point in between those. So let's compare curve fitting and interpolation. So with curve fitting, you had something like this. And you're gonna, we're not assuming the data points are exact in this case. We're assuming there's random fluctuations. In the data, and you're looking for the overall trend. But interpolation, you would have something like this, and now you're assuming these are exact values. And you're looking at, instead of an overall trend, you want specific data in between. So hopefully that gives you a big picture of what interpolation is versus curve fitting. We will start with linear interpolation. So what linear interpolation means is that you are drawing a straight line in between two data points. In MATLAB, the function is called interp1. So what you need to do linear interpolation is you need 2 data points. And remember, these 2 data points we're assuming are exact. So let's call them x1, y1 and x2, y2. Now what we want to do is we want to find an approximate y value. We'll call this y star. This is what we're looking for. Given that we have an x star value that is in between x1 and x2. So where are you going to use interpolation? You'll use this a lot, I will tell you, in your upcoming engineering courses. So for example, in thermodynamics, there's all these tabulated values that you can look up. But they don't have, an infinite number. They only have discrete points. And so you'll have some specific, x value that you want to look up, and it won't be there. And so you'll have to figure out what the y value is for your x value that's in between two values that are given in the table. So you will be using interpolation a lot. And we can do this in MATLAB. What fun. So here is our plot. Let's assume we have these 2 points, x1, y1, and x2, y2. And then we're given an x value, x star, and we want to find the y value for it. So we're going to draw a line in between these 2. And then we're going to find what our y star value is. So to write the equations, we'll use similar triangles. So we have one triangle that is like so. It goes from x1, y1 to x2, y2. And we have another triangle that looks like so. It goes from x1 to x1, y1 to x star, y star. And so we can set those equal to each other. Just writing out the distance. I'll write this out for you. So you have, on this line right here, you would have x2 minus x1, and here you'd have y2 minus y1. Over here you'd have y star minus y1, and here you'd have x star minus x1. So the angle is the same, so you can just set those equal to each other. So we'll do it like this. Okay, equation alert. Anybody who's not taking notes, write this down. You will need to use this equation. Whoops, plus okay, straightforward how I got from here to here, multiply by x star minus x1, and then add y1 to both sides. Algebra. So, given x star, given 2 points, y1, x1, y1, and x2, y2, you can find y star using linear interpolation. This is the equation you will use. You only have one known because x star should be known. You should know at what x value you want to find the y value for. Now, this is linear interpolation, which is of order 1. Oh, let's talk about higher order interpolation first. So let's say, this wasn't going to cut it for you. Perhaps you had a plot that looked something like this. And you wanted to find like you were using linear interpolation, then you would find a value something like this. But if you were to fit a higher order through all these points, it would give you a different value there. So when you're using higher order interpolation, what you're doing is you're using more points. You're doing a more complex calculation, but it's giving you higher accuracy. So this is a trade-off you have a lot in computations, where you do something that's more difficult. It's actually, I mean, it's a little bit more difficult for you to program, but actually what it means is it's going to take the computer longer versus something that's easier, and it's going to give you a more accurate solution. So this is a big trade-off when you're doing humongous computations. You want to decide how much accuracy do you actually need. So we have the type. We talked about linear. The order of linear is going to be 1. It's first order. The equation that you're going to fit between the 2 points is just the equation of a line. And then how many points do you need? We needed 2 for linear. And then if we look at a plot, it would look something like this. 2 points, you're just drawing a straight line between it. So the next type would be quadratic, which is order 2. Now you're fitting a quadratic. Now you're going to need 3 points, and it's going to look something like this. So let's say you have 3 points. You're going to fit a curve between all 3 of those points, and now you can find a line, a point, like a y value, anywhere on that curve. So you could find it here, or you could find it here. And then if we go up to cubic, you can start to see a pattern. And that's going to be, you're going to need 4 points, and now you have something like this. You're going to fit a 4th order between it, and then you can find, you're going to interpolate anywhere along that line. So what we get from this is our order n, how many points we're going to need is going to be n plus 1. So if you have an order n, you're going to need n plus 1 points to interpolate with that higher order. And obviously the computational cost goes up as you go to higher orders. So that's one thing we can do to make it more complicated. Another thing we can do is do it in more dimensions. So let's say you had multi-dimensional data. So what if we wanted to do 2D instead of 1D interpolation? So there are MATLAB functions for this too. You would start using interp2, or there's interp3, and so on. So we'll do, this is still linear, we'll see. We're going to do linear 2D interpolation. So now, when we're doing it in 2 dimensions, we're going to need 4 points. So let's say we have x1, y1, and now we have z. So we'll say this is z of x1 and y1. Now we have x1, y2, and z of x1 and y2. Then we have x2, y1, oops, and z of x2, y1. Okay, so we have these 4 points. So we have an x and a y and a z now, and we want to interpolate. We're looking for the z value. So we're trying to find z star now, and we know x star and y star. So if you look at a plot example of this, you're going to have your 4 points. Right now I'm just showing you, you have a regular, assuming you have a regular grid of points. This is something where you use, MATLAB, you have that mesh grid, generates you a regular grid of points. So if you have that and you know the z values for those, you can find the z value, interpolate to find this. So how we do this is we do this in 2 steps. So let's say we know we want to find x star. we'll label our points here, x1, y1, x1, y2, x2, y2, and x2, y1. So we're trying to find the z value at, let's say, x star and y star. So the first step is going to be interpolate 2 times in one dimension. So let's interpolate in x first. So I'm going to choose to interpolate here and here. So I'm going to get a value there and there for z. So this is going to be my z of x star, comma y2. And down here I'm going to have z of x star, comma y1. And now my second step is to interpolate once in the other direction. And this, you want to do it based on your 2 interpolated values from step 1. So we're going to start at these 2, and we're going to interpolate between them. Because we're doing linear interpolation, so we're drawing straight lines to get at this point here, y star. And now we're going to have a value for z of x star, y star. Okay. So that is how you do 2D interpolation. And as you can imagine, we could do this with more points. So we could have 2D interpolation that's quadratic or cubic, and things will get really complicated. You'll have a lot of points and equations to deal with. So we'll stop at this point for now. So how do we actually implement this? How do we make it useful in MATLAB is the first question. So what we call this is window interpolation. Rarely are you going to be given 2 points and someone's going to say, okay, find this value in between those 2 points. More likely, you're going to have a whole ton of x and y points, and somebody's going to say, find this 1 point, or find a whole bunch of points, right? So let's say we have a whole set of data, x and y. So we have like x1, x2, dot, 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 all the way to xn. We have the same thing for y. So not so different than our scatter plots when we were curve fitting. We have a whole bunch of data. And what we want to find is we want to find y star. And let's say we have a whole bunch of those, so maybe y star of j. And we know a whole bunch of x stars of j. So we're trying to find a lot of data. So how you want to do this is you need to find, where do I interpolate? Where's the window that I'm going to interpolate each of these points from? So the first thing, very first step, we'll call this step 0 even, before you get onto things in MATLAB, is you want to make sure each of these data points, so let's just take the first one, x star 1 and y star 1. Let's make sure that those are we're looking for the y star for the x star value. So let's make sure this x star that we're given is we actually have data for that. We want to make sure we're not extrapolating, we're interpolating. So first we'll check to see if it's actually inside this range of x's that we have. Oops, we'll write it like this. So is x star less than x of n and greater than x1? Let me write that again for you if that is difficult to read. So this is, we're checking to see, we don't want to extrapolate. So extrapolate means to find something outside of the range of data that you have. Right now we're just doing interpolating, which means finding something within the range of data that you have. Okay, so that's step 0. Now step 1. So this is something that you're going to have to do on your programming assignment. These steps would probably really help you if you wrote them down now. So, yeah. Okay, so step 1, now we want to find the window. So we want to find those 2 points that we're going to interpolate. So now we have x star is in between 2 points. So you're going to be searching your data. You could think of different ways to do this. You could use logical indexing to do this. You could use a for loop. You could use a while loop. You're going to search your data and find where is x star, which 2 data points is it in between. And for now, we'll call those xi and xi plus 1. So one side note, what are we assuming about our x data? We are assuming that our x data is sorted, that it's starting at the lowest value and it's going to the highest value. If your x data is all jumbled up, you're going to need to sort it before you do anything else, because you can't interpolate with data that's not sorted. So we find the window. Now once we have the window, we can plug in our formula. Do you want me to write the formula down again, or did you guys write it down the first time? Okay, you probably have it. So y star equals yi plus x star minus xi divided by. So now I'm using xi's and yi's because these are going to be, originally we were doing x1 and x2, y1 and y2. Now I'm using i's because we don't know. It's not going to be the first data point necessarily, the first and second. Okay, so this is what you're going to put into MATLAB to actually interpolate. Now, once we've interpolated for one value, we can repeat this whole thing for our other x values. And then we'll have a whole new set of interpolated data. Okay, so we have 10 minutes. We're going to do an activity that will be really fun. I need volunteers to come up here in front of the class. Anybody? I don't have any candy. It will just rot your teeth. Okay, so come on up. All you have to do is hold a piece of paper up above your head and kind of move around a little bit. Come on up, guys. You'll learn more about interpolation. I can't do it by myself. Thank you. Okay, you get to be Matt. So go ahead and write your age, which is age 21, and you text 3,980 times per month. Okay, so just write your age is 21, and how many times you text is 3,980. Thank you. You are going to be Mark. You're age 29, and you text 2,005 times per month. Come on, guys. I need more than 2.
3,980.
3,980, yes. Thank you, Luke.
Mark.
Okay. You are named Baylor. You're aged 39, and you text 1,430 times per month.
So Mark is 29.
Okay, you are... Okay. You are James. You're age 62, and you text 34 times a month.
Oh, man.
I'm 39, right?
You are 39. You're Baylor. 1,430.
How many times do I text?
You are 29. You text 2,005 times.
39, 40. Okay,
Uh,
I'm sorry. I keep
Okay,
asking.
I was.
Passing the markers.
I think
on.
I'm 39.
Did
I have
these
not been
work? I don't
assigned
know.
a.
Yeah, I need
Okay,
another
got
mark.
another one? All right.
Okay, what was that again? I'm like 62.
You
I think I'm
are
39,
Richard,
40.
I didn't know
age
what I am.
81. You text 3 times per month.
Richard, 81.
Yeah.
Okay, who am I again?
You are
I was like
your name?
62 years
James.
old.
Yep,
James.
62.
And I was right
and you
after
text
James.
34 times.
I was right after James. I didn't
You
have
are
a pen.
Brandon. You
Brandon.
text 907 times. You're age 46.
How many times do I text?
What's your name? James.
James.
You text 34 times.
Yeah.
Okay, so
Wait.
go ahead and
I'm
line
so
up there. You have
popular.
your
I was
sheet.
1430.
I was
right?
900 something.
What was your name?
Brendan.
Brendan. You are 907. Okay, I need one more person to be my interpolation point.
Can I see my number again? I'm
Yeah.
sorry.
You are
I'm supposed to-
39.
Yeah.
You're
I didn't really
1430.
Yeah, I wrote that away wrong number.
Okay,
I don't know
great.
this.
I'm gonna have you wait a minute. Actually, you can okay, you're gonna be Bertha and you're
rewrite this
61
bigger.
years old, okay? But don't get up there with everybody else.
I have a piece of paper. I wrote really small.
Yes. Okay, the first thing you guys need to do, so they have their age and how many times they text per month. So remember what we needed to do with our data before we interpolate? Sort it. Can you guys sort yourselves? Please. From increasing from the youngest to the oldest.
How old are you?
Yeah, so you're Bertha and you text 60, or you're 61 years old, sorry. Okay, Brandon, go ahead and get in there. Okay, so this is our data set. We have X is age and Y is number of times they text per month. So this is Matt, he's age 21, he texts 3,980 times per month. Mark, age 29, texts 2,005 times per month. Baylor, age 39, texts 1,340 times per month. Brendan, age 46, texts 907 times. James, age 62, texts 34 times. And Gertrude, age 81, texts 3 times. This is Bertha. Bertha is age 61. How can we figure out approximately how many times Bertha texts per month? Okay, first, step 1, we need to see, is it inside of our data range? What's your age? 61. Yes, we're inside our data range. We go from 21 to 81. We don't have to extrapolate. Great. 2, we need to find our window. What window? Can you go insert yourself in the window that you need to be in so we can find our 2 data points? Okay, there is Bertha, age 61, in between James and Brendan. Now we need to calculate how many times per month Bertha texts. Can you guys do that calculation? Should I do it in MATLAB for you?
Do it in MATLAB.
Okay. So, I'm going to have y star equal, we'll say text, the number of text is equal to, where's our equation? Okay, so we have the lower point, the y value is the number of times that Brendan texts is 907. Then we're going to add the difference in their ages. So Bertha is 61 and Brendan is 46. And we're going to divide by the difference in the total ages between the 2, James and Brendan. So now we have 62 minus 46. Then we need to multiply that by the total difference in text. So we have, we have to do this in the same order. So 34 minus 907. Okay, so what am I missing? Too many parentheses. There we go. Okay, so that's on the top. Okay, let's see. Did we get it right? 88 times you text per month, Bertha. 89. So, did we put that in correctly? Does it seem reasonable?
Yeah, Bertha's pretty old. Goes from 907 to 30.
She's also 14 years old.
Yeah. She's closer to, well, he, she, whatever. Closer to 62, so yeah.
Okay, great. Good check. Nice work, guys. A big round of applause for all of our volunteers. Thanks, guys.